My name is Katie Moncrief. This is Emily Armitage, and this is Natasha Radosevich. We are in the Microbiology Capstone course, and we are collaborating with the Wyoming Medication Donation Program on our project about antibiotic resistance.
So we are testing influent wastewater samples from different counties around the state in order to explore antibiotic-resistant bacteria prevalence. We hope to elucidate the effectiveness of the WMDP on bacterial antibiotic resistance in Wyoming.
Our general hypothesis is that counties that participate in the program will have less antibiotic resistance per capita than counties that don't.
In this schematic, you can follow antibiotics from prescription to disposal, both appropriate and inappropriate ways of doing so. It shows a sick person seeking a prescription of antibiotics. From here, the antibiotics are either flushed down the toilet, finished, or donated to the Wyoming Medication Donation Program, where they are recycled or incinerated. This shows how inappropriate disposal, such as flushing unused antibiotics down the toilet, can lead to bacterial antibiotic resistance in wastewater, because low doses of antibiotics commingling with the bacteria present can provide selective pressure necessary for the bacterium to develop antibiotic resistance. It also shows our methods used to test our hypothesis. The first step was obtaining influent water samples by mail from the 6 Wyoming counties we chose to study: Sheridan, Laramie, and Albany, who participate in the WMDP, and Sublette, Carbon, and Niobrara, who don't.
We prepared media to sustain bacterial growth from the water samples. We prepped a general media, TSA, McConkey agar to select for coliforms, and TSA plates containing either ampicillin, tetracycline, or gentamicin. We diluted and plated the influent water to obtain growth on non-selective media. Our goal was to obtain between 30 and 300 colonies on a plate to be used in replica plating. This method allows us to use velvet to create a stamp in order to create identical plates on selective and differential media. We replica plated this growth onto McConkey mug to identify gram-negative lactose fermenters, a trait of fecal coliforms, our target bacteria, and plates with antibiotics in them in order to grow bacteria resistant to those drugs.
After that, we conducted a Kirby-Bauer susceptibility test in order to look for multi-drug resistance. This entails using small discs that contain antibiotics and placing them on Mueller-Hinton plates to enhance diffusion. These plates are then inoculated with bacteria. After incubation, zones of inhibition, which mean clear zones with no bacterial growth, are measured to tell us how susceptible that organism is to the antibiotic. So far, we have analyzed the number of colonies on the plates containing antibiotics and compared them to the growth on the non-selective media. We have taken this ratio and once again compared it to the population of the county it came from. So far, this preliminary data shows that there is comparatively more antibiotic resistance from counties that do not participate in the Wyoming Medication Donation Program. From here, we are continuing Kirby-Bauer susceptibility tests and will create a total antibiotic resistance profile of the isolates from each county.
We would like to thank Natasha Galizzi, the program manager at the WMDP, and all of the people who work at the wastewater treatment plants at each county who sent us samples, and our project supervisors, Dr. Gerard Andrews, Dr. John Wilford, and Rachel Watson. Without them, this project would not be possible.